Okay, and again, yesterday we did example number 1 and example number 2. Sorry, I say yesterday, I mean Tuesday. So let's look at this example here. It says in concentration and dilution problems, you're mixing together two things to produce a new mixture. So, this could be, just adding water. You could be making solutions by adding water or alcohol. You could be making ointments, all sorts of things, all sorts of mixtures. The concentration of the active element in the new mixture is either increased or decreased. The words that we use for this are if it's increased, if the concentration goes up, it's called being concentrated or concentration. And if the volume goes down, it's being called diluted. So the amount of active ingredient in mixture 1 plus the amount of active ingredient in mixture 2 equals the amount of the active ingredient in the new mixture. So we're going to look at this type of problem together. So look at example number 3 there. It says if 50 grams of a 3% solution are mixed with 120 grams of a 1% solution, what is the concentration of the final mixture? So we have 50 grams of a 3% solution, and I'm adding to that 120 grams of a 1% solution. So the new mixture, oops, let me try that again, is going to be 170 grams or 50 plus 100, and we're trying to find the concentration of X. So you can see the formula here. I'm going to take my 0.3, and so all of these get multiplied together. So 0.3 times 50 plus 0.01, 1% divided by 100 times 120 equals X times 170. And I just solve for X. Pretty straightforward. And we're going to practice this obviously in a second. So if I take 50 grams of a 3% solution and 120 grams of a 1% solution or mixture and mix them together, I will end up with about 1.6% solution. Interesting. There's a little note on the bottom. It says when diluting, the concentration of the dilutants like water are 0. We don't worry about those. When concentrating, the concentration of the pure ingredient is 100. Okay, so let's look at this example here, example number 4. I'll do example number 4, and then maybe you guys can try example number 5. So if 40 milliliters of a 5% solution is diluted with water, excuse me, such that we end up with 500 milliliters of solution, what will be the percentage strength of the resulting solution? So this one is a little different than the previous example. Notice here it says when diluting, the concentration of the dilutants of water are 0. So the idea here is okay, well, how do I want to do this one, or how do I want to present this one? So here, if I made those boxes, I have 40 milliliters of a 5% solution. Then I'm going to add to this some water. And it doesn't say in the question how much water I'm going to add, but I do know that it's 460. But I'm going to add water, and it's going to equal 500 milliliters of, what I'm trying to find of X. Now, it mentioned earlier in this note here, when diluting, the concentration of the dilutants, like for example, water, are 0. So that means that I don't actually need to put this into my calculation. This is clearly written by a math person, because if we were doing this in chemistry, we would use a different formula, but this works. So I'm going to take 40 milliliters of a 5% solution, so 0.05, and I'm going to times that by 40, and that's equal to x times 500. And I'm just going to solve for x, and that's it. Again, this mixture here, the water that we're adding, because the water is 0%, I'm crossing it out. I don't need to include it. So 0.05 times 40 is 2. I'm going to divide that by 500. And my answer is, hold on here. I'm getting a very small number, but that's okay. So my answer is 0.004. I'm going to times that by 100. I end up getting 0.4%. All right, so that's it. That's a dilution problem. So I'm going to give you guys a couple minutes. You can try example number 5 down below. I'll leave example number 4 there for you. But why don't you guys take a couple minutes and try number 5, and I'll come back and I'll look at the answer. Okay, no answers in the chat. You guys are pretty quiet today. That's okay. Let's look at example number 5. So a cortisone ointment is a mixture of lanolin, which is the base, so kind of like the cream, I guess, and cortisone. How much lanolin should be added to 300 grams of cortisone ointment, 3%, to make a 0.4% ointment? So for this question, we're going to, um, use the formula from above. Oh, and I have a message in the chat here. Ooh, okay, 22.5. Let's see. Let's check it out. So, again, it mentions up here when constant, or sorry, the formula, we're going to take the first mixture, add it to the second mixture, and it will equal the final amount. So, a cortisone ointment, lanolin is added to. So lanolin, we're trying to figure out how much. So I'll do my 3 boxes here. You don't need to draw the boxes, of course, but I'm trying to figure out how much of this I'm going to add to 300 grams of 3% lanolin to make a 4% solution. Okay, so this one, okay, so this one, I just took a minute there to think about this one. Um, we are making a three, or sorry, we're looking to make a 0.4% cortisone ointment by weight. This one's a little bit different than the other ones. First of all, what I'm going to do is I'm going to figure out how much cortisone, the active ingredient is in my solution. So 300 grams of my cortisone is only, so again, I can sorry, I'm just going to scroll up for a second. I can use this formula here. The amount is C times Q. I'm trying to figure out how much cortisone is in the 300 grams of my 3% solution. So the amount of cortisone that's in my solution would be my concentration times my quantity. So 3% times 300, or again, we don't use percents in our calculations, so this would be 0.03 times 300. So decimal 0.03 times 300, and I figure out that there is 9 grams of cortisone involved in this equation. Now, I'm trying to figure out how much lanolin, how much of my quantity should be added to make this a 4.4% solution. So what I'm trying to do is, I'm going to take this 9 grams and sorry, I'm going to take my point, sorry, my amount, trying to think of like how to word this in a way that it's simple. I'm trying to figure out how much I'm going to need to make a 0.4% solution. So 0.4% is equal to the, how am I going to word this? Just give me 1 second here. All right. Sorry about that. I'm trying to, these formulas aren't the best here. So what I'm trying to do is I'm trying to make a 0.4% cortisone ointment. So I'm taking 9 grams of the cortisone and I'm trying to figure out how much solution, how much, lanolin will I need to add to create a 0.4% solution. So what I end up doing is I'm going to take 9 over x is equal to 0.004, and I'm going to solve for x. So that means that x is going to equal 9 over 0.04, and that's where I get the 2250 grams. I'm going to need to make this mixture or add enough lanolin to equal 2,250 grams. So almost on this question, this is a tough question actually, or like it doesn't really follow any of the formulas. The problem with this question is it's how much lanolin do I add to make this? Well, I already had 300 grams, and I'm going to make it up to a final volume or final, not volume, but final amount of 2,250. So the amount of lanolin added is going to be 2,250 minus 300. So that's where I get my answer. Subtract 300, do this on my calculator. 1,950 grams of lanolin added. Okay, so let's look at where this answer comes from. So it says a cortisone ointment is a mixture of lanolin and cortisone. How much lanolin do we need to add to 300 grams of this ointment? We're trying to make a 0.4% solution. So the first thing I did was I figured out how much cortisone was in the 300 grams of 3% solution. So 300 times 3%, or, I converted the percent to a decimal, told me that there was 9 grams of cortisone in the initial ointment. Now, what I wanted to do was to figure out the amount of dilution here to make a 0.4% solution. So that 9 grams of cortisone was being divided by the amount of new solution over 0.4%, which obviously I changed to a decimal. So I figured out over here, right, that I would need 2,250 grams total of new solution to create a 0.4% ointment. And the only last part of this question was to figure out how much lanolin, then how much ointment, how much dilution agent I would add to give me 2,250. Well, if the final amount of that ingredient was 2,250, and I already had 300, then I only needed 1,950. Little weird question. It was kind of done in 3 parts here. But, totally doable by you guys. So let's look at another one. Let me check the chat first. And Kalsum said, I did it a bit different, but got the same answer. That's the thing. That's what kind of took me a minute or two to solve this, is because there's so many ways to do this. But if you got the same answer, that's awesome. So let's look at example number 6. It says 3 samples of a plant have the following potencies. If the 3 samples are combined, okay, so this one is pretty straightforward. Like this one, example number 6, we can use this formula here. So for example, I'll set it up, but I'll get you guys to solve this. For example number 6, we're adding together 3 samples of a plant. So we have 220 grams of with 2.4% strength. We're going to add that to sample 2, which is 50 grams and has 1.97% strength. And then we're going to add this to 450 grams, which has 3.85% strength. And that what you guys are trying to find is what is this percent strength? Now, remember, we're adding all of these together. So we're going to get 220 plus 50 plus 450, which is 720 grams. If anybody's wondering where the 720 comes from, it's from adding together all three of these amounts. So I'll put myself on mute. This one's a lot easier than the last one, or at least easier to think about. We're just trying to solve X here at the bottom. So I'll be back in a minute and we'll check your answers. All right, one more minute and we'll look at the answer to this one. If anybody has the answer, you can put it in the chat there. Ooh, okay. So getting lots of answers in the chat and they're all the same, which is a good thing. Okay, so let's do this. Let's check it out. Now, first thing I'm going to do is I'm going to add together these numbers on the left. Now, to do that, I need to change, don't forget to change the percents to a decimal. So for the first one, let me clear my calculator here. So 220 times 2.4% which is 2.4 divided by 100, of course. I end up getting 5.28. You do not need to write all this down, by the way. The second one, I'm getting 50 times 1.97, which gives me 0.985. And the third one, 450 times 385 divided by 100. Oh, I get a big one here. So 17.325 equals 720 times x. Okay, cool. So now I'm just going to solve this. So I'm going to add up everything on the left. Just give me a second to do that. Oops. So I get, when I add up everything on the left, I get 23.59 equals 720x. So x is going to be 23.59 over 720. And I get, let me just check the chat here to make sure everything's going good with my calculation. Yeah, so I get 0.0328. Now, one thing though, this number, and a lot of people got this in the chat, that's great, but don't forget that this number is a percent, or what I'm looking for, I should say, is the percentage strength. So I'm going to multiply that by 100 to get my final answer. So what I end up getting is 3.27%, or 3.28%, sorry. I was looking at my calculator, not on my screen. So a lot of you guys said decimal 0.328. That's fine, but this would be 3.28%. Perfect. Thank you, Reem. Excellent. All right, cool. So, excuse me. Example number 7 has a solution for you. Well, how about this? We'll look at example number 7. And then you guys can maybe try some of these problems for practice. There's a million of them for practice. Wow, look at this. And then there's method 2. We'll look at method 2 on Sunday, and then we'll have this chapter finished. So let me go back up to example number 7. Let's look at that. Then I'll get you guys to try one, and then I guess that'll be pretty much it for today. And I strongly recommend, like over the weekend, for you guys to try the rest of the examples, like 11, 12, 13. Try these for practice. But let's look at number 7. Okay, so just give me 1 second and I'll read this out. We'll look at the answer and then we'll do one more. All right, so a pharmacist has to dilute a solution to make a product of lower strength. Okay, so you're making a medicine, it's too strong, or what we would say is too concentrated. We're trying to lower the strength. The prescription calls for 90 milliliters of an 8% solution of alcohol and water. So it's 8%. The pharmacist only has access to 20% solution and must dilute this or combine this with water to achieve the 90 milliliters of 8% concentration. So the question is, how much of the 20% solution and how much water are needed? So again, think of this like this is a lot of words and a lot of language here for a very simple question. I'm trying to take, or sorry, I'm trying to make, not take, but I'm trying to make 90 milliliters of an 8% solution. Okay, so hold on. I can't write on my screen. Give me 1 second here. I'll fix my pen. Okay, there we go. So I'm trying to make this solution, 90 milliliters of 8%. The problem is I have a 20% solution on the shelf and I need to dilute this with water. So the question is, how much 20% solution will I make, or will I need, sorry, and how much water will I add to that? So the solution, the amount of alcohol in our final 8% solution must be the sum of the alcohol from the 20% solution and the amount of alcohol in the water, which is 0, of course. We're just adding water, so there's no alcohol in that. So what we're going to do is we're going to let X be the amount of 20% solution needed, and 90 minus X is the amount of water needed. Now, let me explain that. So if we're making a 90 milliliter solution, okay, so like you can just imagine here, we have 90 milliliters of solution. We're going to let the amount of 20% be the X, and 90 minus X. Oops, sorry. My brain is like not working as fast as my mouth. 90 minus X will be the amount of water needed to make that 90 solution. So X will be the amount of 20% solution. 90 minus X is how much water we're going to add to that. So a little bit challenging in the setup. So what we're going to do is we're going to write an equation which represents the amount of alcohol in each of the ingredients. So in the first ingredient, the amount of alcohol will be the 20% solution. So 0.20 or 20% times the liquid. And then in the second one, it's 0% because we're just adding water. So 20% times X, or 0.2 times X, plus the amount of alcohol in the water, which is nothing, is going to give us this solution. This is actually what we did in question number 2 or 3. Same kind of thing. So 0.08 times 90 divided by 0.20, we figure out that we're going to need 36 milliliters of alcohol. You calculate that out, it's 36. So we're going to need 36 milliliters of the other solution. So how much water do we need to add? Well, it would just be 90 minus 36. Actually, so we did this question. This is the one I struggled with. I didn't really know how to show you the answer. We did this with example number 5. So this is the exact same as number 5. Okay, so how about for the end of today's class, let's just do one more, and then I strongly recommend you guys practice these. So, try 12, 13, try 14, but let's do one more. Which one do we want to do? Let's see. So, okay, well, let's do number 8. Okay, I'll put myself on mute. I'll give you guys a couple minutes to try number 8. We'll look at the answer, and then that's it for today. All right, so let me know in the chat what you get for number 8. There's a message in the chat here. I won't say the name, of course, because it's a private message. It says this student I don't think didn't really get number 7. Number 7 was actually the same as I did for number 5. There's not much I'm going to say right now. What I'll say is try number 8, this example here, and then hopefully I can explain the answer, including number 7, once people have tried number 8. All right, so give number 8 a try. I'll hopefully be able to explain 7 and 8 when I do them together. All right, so just take a few minutes for this. Ooh, I'm sorry. Sorry, I'm going through the answer here. This is a tough one. Example number 8 is definitely challenging. So, good luck, and I hope somebody can try the answer or get the answer. But I'll be back in, let's say, 2 minutes at 10:55 with the answer. All right, I got one answer here from Calcium. It's close, but it's not what I got. I'm not saying I'm right either. We'll do this together in a minute. This is a tough one. Number 8, definitely tough. Okay, so let's look at it. Okay, so let me check the chat here before I move on. Ooh, so asthma gave me an answer 15.7, but there's a reason I know that that's not right, because we're trying to make 12 liters of a solution. So the answer cannot be over 12. All right, so let's look at this one together. And like, I love that you guys took the time to do this. This is a tough one. So what we're doing is we're mixing together two solutions to make a new solution. And we have a lot of information here. So it says how many liters. So, I mean, obviously that's going to be our X. How many liters of a 25% solution must be mixed with a 40% solution to give us 12 liters? And again, asthma, your answer of 15 can't be over 12 because we're only trying to make 12 liters of a solution. So if you think about this, you know, we're mixing together a few things. We're saying, and I'm going to erase this in a minute, but we're taking 25% X, you know, like we don't know how much of this. We're going to add this to a 40% solution. And I, you know, like, what do we call that? I'll get to that in a minute. And we will make a 32% solution that is 12 liters. Now, you'll notice in my equation here, I'm missing a very big part of this. I'm missing the 40%. Think about this, and this is what took me a minute to solve this, is, well, if you know, X is the amount of 25% solution, and we're only making 12 liters, excuse me, then the amount of this solution, so I'm doing this here, must be 12 minus X. Okay, I told you I'm going to erase this in a minute, and because I need the room to do the calculations. But think about it. If this is X and this is 12 minus X, then that's what's going to make us the 12 liter solution. If I'm adding X to 12 minus X, it will equal 12. Okay. So now I'm going to erase those boxes and I'm going to solve this equation. Okay, so everybody good with that? Actually, I could maybe I could leave the boxes there. Maybe I can, yeah, I think I have room. So this is going to be 0.25x plus 0.4 times 12 minus X equals 3.84. Now, if you're wondering where the 3.84 came from, it's just 0.32 times 12. I just multiplied those numbers together. Okay, so I multiply all of this out and I end up getting, oh, I skipped steps on my own notes. How am I going to do this? So, guys, I'm multiplying this out, or, you know, solving the left side. So what I end up getting is 0.25x plus 4.8 minus 0.4x equals 3.84. And again, like, I'm just going to go quick through this. I'll solve this. So what I end up getting is negative 0.15x equals negative 0.96. X is going to be 6.4 liters. That was a tough question, actually, and a good one to kind of finish the class on. That was a tough one, and some of these down here might be tough as well. I highly recommend you practice this weekend. Try some of these examples. The answers are on D2L. So try some of these, because not tomorrow, but Thursday, but Sunday, we're going to start method number 2. So yeah, try some of these practice problems this weekend. Now, I have a few messages in the chat. Let me get to that before I leave. And let me get the answer here. So asthma, yes. I didn't see this because I was talking when you wrote this, but yeah, asthma got 6.4, which is awesome. That makes me very happy. That was a tough question. All right, cool. So guys, that's it for today. We'll start method 2 tomorrow, not tomorrow, but Thursday. If you have any questions, let me know, but that's it. We're done. Halas. Have a great weekend. Take care. Be safe. Wash your hands. All right. See you guys. Bye.